morning, students. I hope you all are doing well and following my videos. And the last assignment which I had given, I hope you all have completed by now. And as I'm always telling that this is the time to show that you can do something while sitting at home. Follow your passion. Don't think about what is going to happen in future. Concentrate on today. So keep on studying. Okay, and follow the videos of your teachers wherever you have doubt. Means be enthusiastic about it, that we are sitting at home, then also our studies are going on. So that positive thing should be there in mind. And I know those who were facing problem when in class on the lectures were there. Might be there is few must be thinking that that was better than this one. But for few of the students, this digital way of teaching might be an easier way to learn. You know why? Because the videos which we are sending, you can pause in between, you can restart it, you can hear the lecture again and again. So there the learning thing can be increased. Okay. So today I am going to tell you about octal to binary and hexadecimal to binary, then octal to hexadecimal and hexadecimal to octal. So 4 types of conversions. These are little bit different from what we did in the beginning. Okay, I should say this is little bit tough, but once you will concentrate, it will be easier for you to understand. Clear? So octal or hexadecimal binary system, number system to binary. A number is converted to its binary equivalent by substituting the respective binary value for each digit of that number. You know, whenever you will get the octal number or hexadecimal number, what you have to do, that equivalent means whatever number is there, you will have to set the individual digit of the number and then equivalent binary number for every single digit you will count, and then you will merge together. Okay, so let's see how it can be done. First one, octal to binary. The example here, since octal is of 8 bits, na? So here 3 bit 2 to the power 3 is equivalent to 8. That's why 3 bits will be used for binary. Okay, like when you write 1, 2, 4, 8, this method I had told in the beginning. Okay, so we are not going to use it further. Only these 3 will be used, 1, 2, 4, because we are dealing with octal number system. Clear? So when you are using it, octal number system, here what you will do, that first you will see that this one 705 to the base 8, and we want the binary equivalent. So we'll write the digits individually first, 705, and then 7 is equivalent to 111, 0 is equivalent to 000, 5 is equivalent to 101. 3 bits are required. I'm telling you how it can be done with my that board presentation also. I'll show it, but here also if once I'll tell, it will be easier for you to understand. Start from the left hand and start writing 1, 2, 4. Only 3 bits are required. 7. Which digits you will add so that it will be equivalent to 7? Means all these 3. So all these 3 values will become 1. So the equivalent binary number for 7 will be 1. For 0, we need to put all these 3 bits as 0. So the equivalent binary digit for 0 is 000. Same way for 5. Which 2 digits will make 5? 4 and 1. So 4 and 1 will be put to 1 and 2 will be used as 0. So the equivalent binary representation for 5 is 101. This way, every bit will be converted to its equivalent 3-bit binary presentation. If you need 4 bits, so you increase it to 8. If you need 5 bits, then you increase it to 16. This way, you can convert the binary equivalent for any number. And it depends on you how many bits you need. If 3 bits are required, 1, 2, 4. 4 bits are required, 1, 2, 4, 8. 5 bits, then 16. So this way, you will keep on increasing it. Okay. So now the next thing, you will merge all these binary bits together to show the equivalent binary bit for this number. I hope you have understood. Now next Go to the next slide. Hexadecimal to binary. Same way for hexadecimal to binary, all the digits of the hexadecimal number you put it independently, then convert it to 5-bit, 4-digit binary representation, and then merge it together. It will be equivalent to the binary bit. Now 4 bits are required. Then the same thing. What do you have to do? Right? Now 4 bits are required. Okay. So for 4 bits, 1, 2, 4 and 8. Now 4 bits have come. F is equivalent in hexadecimal to 15. A is equivalent to 10. Let's start with F only. For 15, which all digits we need to add here? 8 plus 4, 12. 12 plus 2, 14 and 1, 15. It means all the bits should be set to what? 1, 1, 1 and 1. So the equivalent binary bit for 4-bit representation for F will be 4 times 1. Same way all these digits will be used. After doing this, you will merge all the equivalent 4-bit binary representation to convert it to the binary value. Clear? Next is, we have to convert octal to hexadecimal. Here 3 steps are required. First step, every octal digit will be converted to its equivalent binary number. Then arrange the bits into group of 4 and then arrange each binary group into the hexadecimal number. Okay, this I have explained through the board presentation that you follow once. One example I have shown here, 1076. First, in the first step, individual digits of the hexadecimal number will be written. This octal number will be written 1076. So equivalent binary 3-bit representation will be written. Then from right hand side you will merge 4 bits together. Okay, as I have shown here. When 4 bits are merged together, then you convert it to the equivalent decimal digit. How it can be done? Let me show it to one. Here 4 bits are there. Write 1, 2, 4, 8. Now write the bits from this right hand side. First one is 0, second one is 1, 1, 1. Wherever the value is 1, add those top digits. Okay, leave the 0, 1. Okay, so it will be equivalent to 8 plus 4, 12, 12 plus 2, what? It will be 14. We know that A is equals to 10 in hexadecimal. Then F, if you start from here, A, then B is equivalent to 11. So this way, when you will reach to F, F is equivalent E, E is equivalent to what? 14. So here the value for 14 will put E. Same way these bits can also be converted. Okay. Next is, we have to convert hexadecimal to octal. Same type of conversion as we did for octal to hexadecimal. First, convert every digit of the hexadecimal number to a binary number. Then arrange the binary bits into 3. There we had done first to 4-bit and then to 3 bits. Here the reverse will be used. How? In the next slide I have shown. Write the individual bits, 1F, 0C written, then 4-bit binary representation converted, done. Then from right hand side merge these to 3, make it of 3 group and then convert it to the equal decimal value and then merge it together. You will get the final value. So that's all for the presentation. Now let's start with the manual conversion, which I am going to show with the help of the whiteboard. And once you will do that, please do the assignment attached. Okay, because I am going to conduct a test for this chapter number system. So more you will practice, more you will get the solutions, how to perform every calculation. All the types of conversions you need to do. Thank you.
Okay, let's start with the first thing, what was there in the presentation, octal to binary. And the given example was 705, we have to convert to binary. For converting an octal to binary, I think the last class I had told one example that how you can do it in a shortcut way. So again I am repeating it. You start writing the digits from right hand side starting with 1, 2, 4, 8, 16, 32. This way the number of bits required by you. So we'll write the octal numbers which is given as 704. with a distance in between. Clear? Now for making 7, what all digits can be added to make it 7? 1 plus 2, 3, 3 plus 4, 7. So the bits which you need to make it 7, those bits will become 1, and other than that, other bits will become 0. And for converting octal to binary, the first step, that every bit of the number, every digit of the octal number, you will have to convert to a 3-bit binary representation. So we'll consider only this right hand side, the last 3 digits. So for 7 we need 4, 2, 1. So under that we'll write 1, 1, 1. So the equivalent binary number for 7 will be 1, 1 and 1. Now for 0, all these 3, this is for 1, 7 sorry, and for 0, all we need to make it 0. So what will be the equivalent value for 0 in binary? 0. 3 times 0 is required. After that, for making 5, the digits which are required 4 and 1. In between 2 is 0, we'll put that 0. 4 can be put as 1 and 1 can be put as 1. So 4 plus 1, it will be 5. So this way the equivalent value for 5 is 101. So we have converted every single digit of the given octal number to equivalent 3-bit binary representation. Okay, after this, just combine all these binary bits together. That will be the equivalent binary number. So it will become 111, 000, 101 to the base 2. This is how we can convert octal number to binary. Again I am repeating, single digit of the binary, single digit of the octal number, convert it to equivalent 3-bit binary digit for every single digit of the octal number. So we have done. You can do it by converting it independently, the longest method which was there, but this way it can be done easily by using this shortcut method. Next is hexadecimal to binary. This is also very much similar to that, but here instead of converting it to 3-bit binary representation, we have to convert it to 4-bit binary representation, because all these 4 digits only will become 16. 8, 4, 12, 13, 14 and 15. So how many digits were there in hexadecimal? 0 to 15, 16. Okay, so altogether 16. That's why we are going to take 4 bits of binary now. Hexadecimal to binary. I am taking the example which is given in your book. I had shown it through the this presentation also, the same example. It is 10 AF to the base 16 and we have to convert it to base 2. Clear? Now again here, as we did in the above question, same way independently you write every digit. 1, 0, then A and then F. Do you remember A is equivalent to which digit of hexadecimal? A is equivalent to 10 and F is equivalent to 15. Okay. So for making 1, now leave this one. Again I am writing for hexadecimal now. 1, 2, 4, 8, 16. How many bits are required? 4. So I am not going with 32, 64 and all. Only 4 bits for hexadecimal. So every single digit of the hexadecimal number will be converted to 4-bit binary representation. So for 1, which digit you need to make 1? Only this side 1. Rest of the 3 digits will put to 0. So what is the equivalent number for binary 1? It is 0001. For 0, always those number of zeros you need to put. Now for 10, 8 and 2 will become 10. So these 2 will put to 1 and 4 and 1 will be putting to 0. So A is equivalent to 1010. Same way for F. F is 15. How come we can get 15 here? 8 plus 4, 12. 13, 14, 15. So we can get 15 by putting all the bits as 1. 1, 1, 1, 1. So here, what will be the 4-bit binary representation for F? 4 times 1. Now merge it all together. So the equivalent binary number to 10AF to the base 16 will be 4 times 0, 1, 0, 1, 0, 4 times 1 to the base 2. So this is how you can convert hexadecimal to binary. Next we have octal to hexadecimal. Hexadecimal. Okay, this one is containing 3 steps. The first step, convert every, let me take the example first. So example I am taking 1076 to the base 8, since it is an octal number. We need to convert it to the base 16. Clear? So this is, we need to convert octal to hexadecimal. So same way, first you write these digits separately, 1076 written. Now convert every bit to an equivalent 3-bit binary representation by following the same method which I had told. It was 1, 2, 4, 8, 16. 3 bits we need, so 16 is not required here. Okay, so 1 how can we get? By putting 1 here in this part and rest of the things will be 0. We need 3-bit binary representation as the step told. So here it will be 0, 0, 1. So for 1 we got 0, 0, 1. For 0 obviously 3 times 0. For 7 find out 4 plus 2 plus 1 7. So here 1, 1, 1 for 7. So we'll write here thrice 1. For 6 we need 4 and 2 if we'll put 1 and 1 as 0 it will be equivalent to 6. So it will be 1, 1, 0. We'll put here 1, 1, 0. Here the most important step, since we need it to be 16 to the base 16. Now we'll arrange the digits in a way that it will be a conversion to 4-bit binary representation. We'll start from the right hand side. Okay, so combine it as 4 digit like this 4 together. So it will be 0, 1, 1, 1. Okay, then up to this it will be 0, 0, 1, 1. Then all this together it will be 0, 0, 1, 0. I hope it is clear. Now convert it to the equivalent decimal number as we told here. So write here 1, 2, 4, 8. Okay, so start from that side. It is 0, 1, 0, 0. What will be the value of this? Here in all the places it is 0, so only 2. So the equivalent value for this is 2. Same way for this number 0, 0, 1, 1. These two are 0, so we'll add 2 and 1. Since the digits in this place is only stands 1. So 2 plus 1 it is 3. Next is 1, 1, 1, 0. This one is 0. So it will be 8 plus 4 plus 2. It will be equivalent to 14. And we know that 14 is equivalent to E in hexadecimal. So we'll write here E. So what is the equivalent value here? 1076 to the base 8 is equivalent to 23e to the base 16. So this is how we can convert octal to hexadecimal. Now we'll convert hexadecimal to octal. Hexadecimal to octal. Here also 3 steps are involved. In the beginning, we'll convert every bit of the hexadecimal to 4-bit binary representation, then we'll convert it to 3-bit from right hand side, and then the equivalent decimal number will be written. So just only here we need to reverse it. Rest of the things are similar. Let's take one example. 1F0C to the base 16. We need its octal value. Clear? Now for this, first take every bit as an independent digit of the hexadecimal number. 1, F, 0 and then C. F is equivalent to 15. C is equivalent to 12. Okay. C is equivalent to 12. That you need to remember. Okay. In hexadecimal. Now we'll convert every bit or every digit of the hexadecimal number to 4-bit binary representation. So same step. 4 bits are required. From right hand side, start from 1, 2, 4, 8. So altogether how many bits are there? 4. Now 1, how can you make it to 1? By putting these 3 bits to 0 and this bit to 1. So it will be the equivalent binary representation for this hexadecimal value 1. So we'll put here 3 times 0 and 1. This is equivalent to 15. How can we get 15? By putting all this as 1. 8 plus 4, 12, 13, 14 and 15. So the equivalent value for F is 4 times 1. For 0, 4 times 0, and for C, as I told, it is 12. So for making 12, which 2 bits we need to put to 1? 8 and 4 only. Rest of the bits will be used as 0. So 4-bit binary representation we have used. From right hand side now, we need to cover it, or we need to convert it to 3-bit binary representation. How can it be done? From right hand side you start this one, then 3 bits, then again 3 bits, 3 bits and then 3 bits. The remaining 0, since it is towards the left hand side, it can be discarded. You leave it. Okay, so start writing to the 3 bits. First one is 0, 0, 1. Second one is 1, 0, 0. Third one is 0, 0, 1. Then 111 and then 1, 0, 0. Now convert it to the decimal value. Same way, 3 bits are there. We'll take 1, 2 and 4. So these two values are 0 and this one is 1. So the equivalent value for this is 1. For this one, all 1. So what is the value? 4 plus 2, 7 and then 8. 4 plus 2, 7 and then 8. It will be 7. 4 plus 2, 6 and then 7. Then 1, 0, 0. 1, 0, 0. These two are 0, then equivalent value is 4. Then 0, 0, 1. These two are 0, the equivalent value is 1. Then 1, 0, 0. These two are 0, the equivalent value is 4. So finally we got the actual value for the equivalent octal number. It is 17414 to the base 8. So this is how you can convert hexadecimal to octal. In all these questions, you need to concentrate on this. If you need the 4 bits, then start from 1 to 8. If you need 3 bits, then only 1 to 4 will be used. And wherever the value is 1, you put it 1 and then count only the bits on top which are equivalent to 1. So you will get the equivalent decimal bits as well as binary bits also. So this is how all these conversions are there. I am going to forward an assignment which is based on the whole chapter. By that we'll complete this whole chapter. And I'll try to take one objective type test after the completion of the chapter. So I want all of you to keep on asking the doubts through campus care as much as possible. Thank you.